In these set of videos, we are going to explore some properties and then we'll do some word problems involving special triangles. When we say special triangles, we mean triangles with 45, 45, 90 degrees and the triangles with 30, 60, 90. To start with, let's find the area of an equilateral triangle. So the question here is, determine area of an equilateral triangle with sides of s centimeter. So we have taken a very general question and that's how we are going to proceed. So in this example, we'll find the area of an equilateral triangle. Let us say this is our equilateral triangle and the sides are s each. Now if I drop a perpendicular from here, it is going to divide the base into two equal parts, right? So each will be s over 2, right? So this will be s over 2 and this is also going to be half of the side s, correct? Now area is base into height divided by 2. To find the height, we can use Pythagorean theorem. So let's use Pythagorean theorem and find the height. So in this equilateral triangle, we know all these angles are 60 degrees and this is 90 degrees. Now let's label it. Let's say this is A, B and C and the perpendicular is at D. Now BD, the height of this triangle should be equal to square root of AB square minus AD square. Now AB square is given to us as S, since that is the side length of equilateral triangle. S square minus AD is half of S. So it is S over 2 square root. And that gives us within square root S square minus S square by 4. And if you simplify this, you get 4S square minus S square over 4. And let's take it on this side and say this is 4S square minus S square is 3, right? So we get 3S square over 4 square root. Now that could be written as equal to S over 2 square root of 3. So this is BD, right? So we get side BD as square root of 3 over 2S. Now once we know the base and the height, we can always find the area of the triangle. So the area of the triangle will be half base, which is AC, times BD, which is the height, correct? So let's place the values. So when we substitute, AC is equals to S, the side, and BD, this is BD. BD is square root 3 over 2S. So if you multiply them, what do you get? You get square root 3 over 4 S square, right? So remember that area of an equilateral triangle, let's say equilateral triangle, is always equal to square root 3 over 4 S square, right? This is important to remember. We can ask this question in multiple choice questions also, and if you have an idea of what this is, it helps, right? Now there was another approach to do this also, and that is looking back into our special triangles. So if you know the special triangles 30, 60, 90, so let me draw here one. So in any special triangle which is having angles of 30, 60 and 90, let us say this is 60 degrees, this one is 90 degrees, and this one is 30 degrees. So combination of 30, 60, 90, the sides are in the ratio of 2 is to 1 is to square root of 3. As you can see here, the side is S. If I multiply each by half of S, I get corresponding sides. Do you see that? So these two are proportional triangles since they have same angles. Now if I multiply 1 by half of s, I get this. Hypotenuse 2s. 2 times half of s will give me s, and square root 3 over 2 of s gets me the perpendicular. So at times, if this question has been asked in a multiple choice question, what you can do is you can make this special triangle and straight away get the height. So you don't have to do all this. Do you understand? You don't have to do all this to get the relation that BD equals to S over 2 square root 3. That is kind of straightforward. So it takes just a minute to get the answer, right? So that is what I'm trying to show here. Show you how knowing about special triangles help you to solve the problem and cut down on time. I hope you appreciate it. Thank you.